Hi everyone, this is Sunny Kumar from Mathematics and Computing Part 2 from IIT BHU, and I am back again with the problem shortest path in a binary matrix of Leetcode, and the index of the problem is 1091. Okay, so basically in this problem we have been given a square grid, and the size of the square grid is n into n by n, and each cell of the square grid is either 0 or 1, denoting 0 is going to denote the cell is going to be empty, and 1 is going to denote the shell is going to be blocked. Okay, now what we have to do in this problem is we have to return the length of shortest clear path from top left to bottom right, that is from 0 comma 0 to n minus 1 comma n minus 1. Okay, now note that the path should be clear, that is from path from 0 comma 0 to n minus 1 comma n minus 1. The path, that is the path from 0 comma 0 to n minus 1 comma n minus 1, there shouldn't be any blocked cell. Okay, now the moves are, that is for from any cell where you can move, that is you can move to all the 8 of the neighbors of the current cell. That is, what are the neighbors of the current cell? It is also mentioned in this problem, that is you can notice that adjacent cells are connected in 8 direction, are connected 8 directionally, that is they are different and share an edge or a corner. Suppose you are at, let's understand this problem in more detail. Okay, suppose you are at I comma j, so what are the positions that you can visit from I comma j, that is adjacent cells I, let's say I minus 1 comma j minus 1, and let me copy this and I am going to paste this 8 times. Okay, okay, 3 4 5 6 7 8. Okay, so from I comma j you can visit 8 positions, that is either you move to I minus 1 comma j minus 1, or I minus 1 comma j, or you can go to I minus 1 comma j plus 1, or from the current cell you can visit either to I comma j minus 1, or you can visit to I comma j plus 1, that is to the right of the current cell, or you can visit to either I plus 1 comma j minus 1, or you can visit to I plus 1 comma j, or you can visit to, that is from I comma j to either visit to I plus 1 comma j plus 1. So these are the 8 cells that you can visit to from the current cell. Now the problem says we have to find the length of the shortest such clear path from the top left to bottom right. So what would be our approach in this problem to solve this question in most efficient way? So I have used the method of minimum heap, that is to start from 0 comma 0, that is from the top left cell, and we are going to move to check out the, if going to any of the neighbors from the current cell gives the minimum value to that neighbor, then we are going to push that neighbor into our minimum heap, and each time we are going to pop out from the minimum heap and check out if this has if our current cell has reached n minus 1 comma n minus 1, then we are going to return the value. Otherwise each time we are going to check out the neighbors of that current cell, and we are going to update that value in a dist matrix that is going to store the minimum distance from 0 comma 0, that is the length of the shortest path. So how we are going to do this, what would be our approach, let's understand this. Okay, so we are maintaining a minimum heap of cells, that is using priority queue in using C++ STL. Now what I am going to do is I am going to push the value and coordinates of source, that is here you can see, let me write 0 comma 0, that would be our source here in the minimum priority queue, that is minimum heap. Okay, now since the heap is the minimum heap, what I am going to do is I am going to each time pop the coordinates having minimum value, that is for from the top of the priority queue, and check if going to its neighbors and the cell that we are visiting to, that is neighboring cell, is not blocked with the current minimum, gives the minimum or not. So I am going to tell you with my code also, this will, and I am going to explain you with the example, this will makes you much clear. Okay, now I am going to repeat this third step until and unless we have reached n minus 1 comma n minus 1, or if this cell cannot be reached, the we are going to return minus 1 in this case. So this would be our approach using priority queue. Let's understand this using the example. Okay, now suppose I am going to push the value that is in our minimum heap, the value equal to, let's say, 0 comma 0, and okay, this would be our coordinates, and our value associated with this will be like length. Note that we have to return the length of the shortest path, that is we are going to we are going to push the minimum value, that is current minimum value at the source, that would be 1, and we are going to push the coordinates in the minimum heap, that is we are going to push this value. Okay, now what I am going to do is I am going to check out each time the neighboring cells of this current cell popped out from the top of the priority queue. That is, we are going to pop out this value top of the priority queue. This would be at top of the priority queue because the priority queue contains one element at the starting. Now I am going to check out the neighbors of this cell, that is for 0 comma 0. Note that 0 comma 0 neighbor cell must not be blocked and must be inside the grid, and here you can see from I comma j, the only possible way to go from I comma j, that is to I plus 1 comma j plus 1, that is from to 0 comma 0 here. So what I am going to do is I am going to update this value, that is it would be like 2 comma, and the coordinates associated with this would be 1 comma 1. Okay, note that this 1 comma 1 is actually the bottom right of the cell, so we have reached the bottom right of the cell, so I am going to return 2 from this. Okay, so our, in this case, our length of the shortest path would be 2. Okay, now let's take another example from this problem statement, that is 000, 110 and 110. Okay, so let's take example from this 000, 110 and again 110. So initially I have to push the source, that is 0 comma 0, so it would be like 1 0 comma 0 comma 0, value associated will be 1 because the length of the shortest path including this only cell would be 1. Now what I am going to do is, now I am going to pop out this 0 comma 0 cell and the value associated with this, and I am going to check out the neighboring cells, that is 0 comma 1 and these two cells. Note that the I plus 1 comma j and I plus 1 comma j plus 1 cells are blocked, so I am going to check out the neighboring cells of this 0 comma 0. So the only possible way to go to from 0 comma 0 is from go to 0 comma 0 to 0 comma 1, and what I am going to do is I am going to push this value into again the priority queue, because note that going from this current cell 0 comma 0 to this 0 comma 1 gives the minimum to 0 comma 1. That's why I am going to push this value into our priority queue. It will be much more clear when you go through the code, and I will explain you how this is happening using the priority queue. Okay, now again our priority queue will contain 2 comma and 0 comma 1 only element, because why this is our, let me write, current state of minimum heap. Okay, so this should be our current state of the minimum heap after one iterations, that is after one pop out operation. Okay, so why this 2 is coming here, because from 0 comma 0 to 0 comma 1 the minimum length of the shortest path up to going to 0 comma 1 would be 2 length, that is 0 and 0. Okay, now what I am going to do is I say still I didn't reach the n minus 1 comma n minus 1 and the queue is not empty. What I am going to do is I am going to again pop out the topmost element. Note that the priority queue here contains only single element, so I am going to pop out the topmost element. So our topmost element would be here again will be 2 comma, note that here again it would be 0 comma 1. So I am again at 0 comma 1 position, and now I am going to check out the possible what would be the possible neighbors of this 0 comma 1. Note that this 0 comma 1 can go to, let me write, the possible neighbors of this 0 comma 1 would be either go to 0 comma 3 or go to what, 1 comma 1 comma 3. Okay, as you can see, either go to from 0 comma 1 to from to 8 of the neighboring cells, but some cells are out of this grid and some cells are blocked. So go from 0 comma 1 to either 0 comma 3 or 1 comma 3. Now I am going to push these two elements in our priority queue again, because these two elements from going from current cell to these two cells gives the minimum. So what I am going to do, I am going to push these values in our priority queue. Okay, so what would be the length of this up to these cells, that is up to 0 comma 3 and 1 comma 3, the length of these cells would be, note that going up to 0 comma 3 adds one length of cell to the current cell, that is, note that the current length is 2, and if we move to 0 comma 3 or 1 comma 3, our current length would incremented by 1, that is, it becomes 3. So our current state of the priority queue would contain 3 comma, and the cells coordinates associated would be this, like 0 comma 2, and again it would contain, this is the first element of the priority queue, and again it would contain the cell value associated with the coordinates is 3, and the cell associated would contain 0, sorry, 1 comma 2. Okay, so these are the values associated with this, that is this cell and this cell. Now, one thing you can notice that going from going to n minus 1 comma n minus 1 gives the minimum length of the shortest path would to go to 0, sorry, the minimum length of the shortest path going to n minus 1 comma n minus 1 is achieved only by the value this value, that is from the coordinates 1 comma 2. So in the next step, what priority queue is going to do is, priority queue is going to pick up the minimum value, that is either this or this. Okay, suppose priority queue has picked up this value. Okay, so going from this to its neighbors, that is to this value, to n minus 1 comma n minus 1, the neighbor of or let's say going from 0 comma 2 to its neighbors, that is 0 comma 1 or to 1 comma 1 or to 1 comma 2, doesn't reach the n minus 1 comma n minus 1, but this cell is going to give the minimum value, that is, it is going to give minimum value, like the priority queue is going to pop out this element when its chance comes, like 1 comma 2 comes at the top of the priority queue. What priority queue is going to do is, priority queue is going to pick up its neighbors, that is, and value associated with that neighbor would be 4, and the cell would be marked as 2 comma 2. Note that the 1 comma 2 is 2 comma 2 is the neighbor of the 1 comma 2, also 2 comma 2 is what, the bottom right of the cell, and the value associated with will be the 4. So the priority queue, each time priority queue is going to pick out the minimum and mark all its neighbors with this minimum value, if this going from the current cell to that cell gives the minimum value. So our answer would be 4 in this case, that is go to, how the paths are associated will be, let me write, go from 0 comma 0 to what, 0 comma 1, and again go to the, it would be like 1 comma 2, and again go to what, 2 comma 2. So this would be our path, length of the shortest path. So let's move on to the code sections for better understanding. Okay, so what I have done is, I have made a function that is going to return whether going from the current cell to this neighbors is safe or not. Okay, now what I have done is, I have taken n as a grid size, and if the source or the target is blocked, then we all know that we can't reach, that is, we are going to return -1 as per question. Now I have made a minimum heap which is of type pair int comma a pair. Note that the second element of the pair is going to store the coordinates, and the first element of the pair is going to store the minimum value from the current cell, that is from the source. So it is going to be minimum if the comparator is greater pair int comma pii. Now what I have done is, I have maintained a distance matrix which is going to store the minimum distance, that is the minimum length of the path associated from the source to the target, that is from 0 comma 0 to n minus 1 comma n minus 1, and I have initialized with int max. Note that the source is going to be initialized, that is 0 comma 0 is going to be initialized with the minimum length of the shortest path would be 1, and I'm going to push this value, that is 0 comma 0, to this queue. Okay, now what I have done is I have iterated in this queue, and I have each time popped out the minimum element, that is the value q dot top dot first, and again the two coordinates, and I have checked if this has reached the end of the cell. I have returned the length of the shortest path, that would be current value plus 1, and if this hasn't reached, what I'm going to do is I'm going to check all its neighbors, and if at any time is going to this neighbor cell is not safe, or the neighbor cell is blocked, or we have encountered the same cell as of current cell, or 1 plus the current val is not going to be less than the value present at its neighbor cell, I am going to continue this operation, because the operation will not be fruitful. Okay, otherwise I am going to update my neighbor cell with the 1 plus the current minimum value, that is from the current cell, and I am going to push this value into our priority queue again for further processing, and each time it is going to pick up the minimum value or mark its neighbors with this minimum value plus 1, and if we have encountered the end of the cell, we are going to return that minimum value. Okay, otherwise if any case or the cell is going to be blocked, or the priority queue becomes empty and we haven't reached the end of the cell, that is for we haven't reached the target, we are going to return minus 1 in this case. Okay, let me submit this code and check out. This is going to give the yes, the it is success. Okay, so if you have any doubts, please do not forget to mention in the comment section of the video, and I will ask the users to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this video.